Problem 5-32. Barnaby's grandfather is always complaining that back when he was a teenager, he used to be able to buy his girlfriend dinner for only $1.50. Letter A. If that same dinner that Barnaby's grandfather purchased for $1.50 60 years ago now costs $25.25, and the price has increased exponentially, write an equation that will give you the cost at different times. So some key things there. It says that it is increasing exponentially over time. So how much was it to start out here? Well, he used to pay $1.50. So that's kind of like our initial value. So let's just call that the 0.0 $1.50. Now, since this is exponential, we have y equals a times b to the x, where a is our initial value. In this case, we know a is $1.50 already. B is our multiplier, and we don't exactly know what the multiplier is. We don't know what rate it is increasing at exponentially. Our x is going to represent, it's our input, and it's going to represent the number of years that have passed. And y is going to be the cost of dinner. Now I'm going to go through and I'm going to show you how to do this problem, and I'm also probably going to show you a couple things in the calculator that you may or may not be aware of as we're doing it. So right now we definitely need to figure out what the multiplier is going to be in order to be able to write our function here. So we already know that we had a 0 and $1.50, and it said 60 years later that same dinner costs $25.25. So now, as we take this and look to figure out what the multiplier is going to be, if I take it and I plug in there, y is equal to our starting value, our initial value, which is our $1.50. We're going to multiply that times b, because we don't know what b is, and then we'll raise it to the power of x. So far, we've got our initial value plugged in. We don't know what that multiplier is, but since we know some x's and y's, we could plug that in there. We can't really use the $0.50 because we already are using part of that point. So let's focus on the 60, 25, 25. So if y is 25, 25, it should equal $1.50 times b to the power of 60. Now, just like a lot of other equations and things that we've been trying to solve recently, we're going to have to get our variable by itself. So let's go ahead, before we start messing with the 60, let's divide each side by $1.50. So when we do that, our $1.50 divided by $1.50 is like 1. So right now we're looking at b to the 60th power is going to equal 25 divided by 1.5 or 1.50. Now the next step here is we have to get b by itself. Well, we have b to the 60th power. And we've done a lot of things that we've solved in order to figure out what the base is. For instance, if we had b squared equals 16, we know that we would take the square root of each side. We'd end up in the end here with absolute value of b equaling 4. So we know that b would equal positive or negative 4. Well, in this case, we're going to be doing something very similar to that. Instead of taking the square root or taking the cube root to uncube something, we're going to take the 60th root of each side. So I have the 60th root of b to the 60th power should equal the 60th root of 2525 divided by 1.50. So let's get our calculator out. We're not going to have to worry about the absolute value on this one because we're looking for a positive rate here because we know that the rate is going up as the cost is going up each year. Let's pull that calculator out. And let's type in 60 and math, number 5, so we can set it up as the 60th root. And we have 2525 divided by $1.50. We hit enter and we get 1.048180.724. So this means this is like 104.8%, or that our price is going up 4.8% each year. So what I'm going to do here, this is something you may not know about your calculator, but it can actually store values. I'm going to say, since I just came up with that answer, I'm going to press this button down here called where it says STO. Let's bring up that key sequence here so you can see those. So I'm going to press store, and I want to save it. I'm going to save it as B. So in order to put it in as B, I'm going to have to press alpha, and then I'm going to have to choose where my B is. So this answer will be represented with B from now on. What are we going to do with that? Let me just take this, put this here. Oops, this was 25.25 over $1.50. So this was, we'll say, B was approximately 1.048. However, I don't want to use that approximation when I'm trying to figure out the costs after all the different years here. So let's see here if we can come up with an equation. So B was 1.048. Move up here to the top. We know A was $1.50 and we know B is about 1.048. So if we're trying to come up with a function here, we could say f of x equals 1.50 times 1.048 raised to the power of x, where f of x is like y, it's the cost of our dinner. Remember, this would be approximation because we had to round that decimal. Now let's look at B. B says, how much would you expect the same dinner to cost in 60 years? I'm going to pull my calculator out. I don't know where it went there. Let's get it back out. And let's look at that. Remember, we already stored this percentage here as B. So when we started, actually, let's do this. We already have this chart over here. When we started 60 years ago, it was $1.50. Now it is 25.25. So in 60 years, how many years have gone by? Well, that'd be 60, so we have to add 60 more years onto this. So 120 years would have passed since our grandpa used to take his dates out for dinner. For his girlfriend, my bad. So 120. We're going to want to plug that into our function. So let's do it here. Our function being, sorry, I'm a little all over the place. There we go. We're going to plug in the function of 120 is equal to $1.50 times our approximate 1.048 to the 120th power. If we do it this way, we're going to get a slightly rounded answer. I'm going to show you how off or how different the answer is. If I use this value, it's going to be a little bit greater. So if I do 1.50, so I'll do this one first, times 1.048, and we're going to raise that to the 120th power, and we get approximately $416.34. This is the approximation. If we do the actual with the real value here, let's see what happens. So I'm going to do 1.50. This time, instead of typing in 1.048, remember I stored this other value as B. So I'm going to do alpha, and then I'm going to press the apps button here for B, because I said that this value is B. So I'm going to do $1.50 times this value, and I'm going to raise it to the 120th power. We hit enter, and you'll see we'll get $425.04. So it's going to be $425.04. That is the more accurate answer. This is more of an approximation here, the 416.34. Heck, I guess if you're going out to dinner though, what's the difference between, what is that? About $9 almost there when your meal is costing 400 some. Anyway, this is problem 4-32. I'm sorry, 5-32. It's kind of a long one. But how much would you expect the same dinner cost in 60 years? We said $425.04, or I know I would be fine if you ended up with $416.34 too. So somewhere in that ballpark. This is Mr. Boyd. Hope that this helped you out a little bit. If not, ask someone else, ask me, ask somebody, just do it, get some help. Have a good one.